Minecraft. Now what this video is basically going to be is an execution of a program that I've already loaded in. I'll show you where that is later, and then a bit of a run around the whole area just to show you what each part does really. Now that lever I just pressed clears out anything that may be already stored in the system. We got sort of some memory off in the distance there. It's a fair bit of memory all around, and it just makes sure it's all clear, ready that the program can start running. And yeah, and then when I press this next button, it will actually start running the program. Now the program is stored, you might have just seen it over to your left there, in this big field, and that's actually a memory that I designed just with a manual input. You have to go and put torches in, but it was the easiest way I could fit it into a really small space and have it very easy to select between, probably as quick as I could as well. So I'm just raising myself up here so you can just see the whole thing, and what I'm going to do now is speed up the execution of the program because it is incredibly slow. I'll put some instructions on the screen showing the actual 8-bit instructions that I've fed into the memory, and it is a little bit hard to see, but you'll see to the left of the screen here instructions are being read out from that big block of memory, and they get fed into the set of bars going horizontally at the top of the screen, and that then on the bottom level works out what instruction needs to be run, and if necessary actually loads up an additional instruction into the top level, which what it's doing at the moment is loading values into my RAM memory, which is over at the right, which you can't actually see on this screen. Excuse me. Now the way this works is not ideal. I learnt so much while making it that I sort of wish I could go back and do it again, which is something I may well do at some point. I certainly could have made it faster than it is, and when I started I really didn't know much about this at all, and a lot of it's been learnt while I've been doing it, and also with the help of a couple of websites. So let me just tell you what this program is actually doing. I've loaded in a set of instructions, and what it's going to do is take the number 33 in binary, of course, add 61, then subtract 12 and give us an answer. So it's still running here. Couple of things to point out while it's running. You may see that around the center of the screen it's kind of hidden by a 4 bars that go off into the distance, but the thing just below that is running through, just changed there, is actually a program counter, and what that is literally doing on every clock cycle is just adding 1 to its number, allowing me to access the next section of memory over to the left. Some of the instructions do actually progress it even further. That in particular is something which in hindsight I wouldn't do again, because it can just be quite messy to have an uneven number of instructions for some things while only using 1 instruction for another thing, and I think I could have made a more robust architecture using, perhaps this particular program would have used more commands, but other programs would have used less. That may be a little bit hard to explain if you're not familiar with how this is actually working, but trust me, it was a bit of a mistake on my part. So I believe it's getting towards the end now. I haven't really been keeping track of it while I've sped up the video. Like I said, the instructions will be on screen, and what will happen in a moment when it finishes is it will update a big display that I have behind me specifically for showing the output, and then it will just stop itself. Once that's done, I'll give you a tour around the processor. I'll show you the output just to prove it did actually do something, and then I'll just give you a run around the processor and show you each section. Okay, so Here's the other video, and as you can see at the top and bottom here, it's calculated the value of 82, which is 33 plus 61 minus 12. Now that number 82 is shown in binary, and what I will put on screen for those not very familiar with binary is just how you add it up using the place values of each section. So, oh, that took me by surprise. I don't remember editing that in so fast. Okay, what you just saw back there under the glass was the clock. I'm running here down the main command lines. The central block there where I was standing was kind of an afterthought, just for an easier way to control it really, which is why there is this additional wire leading to where all the commands actually go in. But it doesn't take too long, it's only a couple of repeaters. So only 2 of the commands here are used during the execution of the program. The other ones are reserved mainly for resetting it. Okay, so the instructions come down here. Activate relevant wires over here that will output the program command from the large area of memory over there. Each one is 16 bytes, so I have 64 bytes in total of memory. These here is two sets of registers, each 8-bit, top and bottom. They hold the current instruction, and the wires running underneath here are the instruction, while the ones coming off of it direct that instruction to the area that processes it. Okay, so here we've got the section where the wires meet the main memory module. I call it RAM memory. It's very slow. It's not really fair to call it RAM memory, but it's essentially memory that the processor doesn't need, but I can store values in to load into the processor, and the processor can also write back to it, although I didn't actually do that in this execution. Okay, and then over here, just running around the side, you've got wires that lead round mainly for writing the registers of the system. So down here there's a top and bottom register, which it's ahead a little bit, I'm jumping ahead of myself. The top and bottom registers coming up take any values that have been fed to it and can be written selectively. This bit here decides which one's going to be written. Okay, now we're on the other side of the processor. All these wires going in are wires that allow me to select what operation I want to do, and the big bar over the top is allowing it to feed back to the start of the processor. And at the end here there's 2 more registers. That's just 2 sets of memory that allow the processor to feed back its final answer, and this bar here leads to the end. And the video was slightly shorter than I thought, so I'll just finish up by saying thanks for watching, I guess, and